welcome. So in our previous lecture, we talked about if I had some kind of interval and I was looking at the graph of the function, or really just the function, its values that it takes on that interval, and I wanted to know what is the average value of that function, then there was a way to compute it actually using the integral. And so now I want to do an application of this. I felt like temperature was something that we could all relate to. So here's the question. So the setup is that I have a daily outside temperature that's given by this equation. Okay, so that's my function. Something that we'll deal with in a moment is the fact that there's a t in there instead of x. We've been dealing with a function f of x. Now we're dealing with a function t of t. That's okay. We just have to make sure to adjust everything to correspond exactly. And then we have, so I mentioned here also the units that things are measured in. So our time is measured in hours, but really the hour in the day that it is. And the temperature is going to be measured in degrees Celsius. And then the question is the average temperature between, so I have the time 6 hours and the time 12 hours. So we're on an interval. So this should work. So let's start working our way through it. And the first thing to do here is so I'm going to start with the solution. And the first thing to do is to kind of remind ourselves of which formula we're going to use and then figure out how what we have here fits into that formula. So we're going to want to use, so we want to take this formula that we have. So we have f. So f is our function, and we have that if I want to take, so I'm going to take f, average, is going to equal, so then I take 1 over the length of my interval. Okay, and then I'm going to have the integral from, and then I'm integrating over that interval, so all the x values that are contained in that interval. And then I have f of x, so my function f, here we're assuming it's a function f that's a function of x, so x is my variable, and dx even further indicates that I'm integrating with respect to x. Okay, so we want to use this, and now we have to translate what we have into what's in the formula. So let's look at what's in here for a second. So this is the function f of x, right? So we need to look for the function that we want the average of. And we're asked to find, so we look at this, we're asked to find the average temperature. So I'm trying to average the temperature function. So I must be looking at the average of this. And maybe I can even emphasize here the fact that I'm writing average temperature tells me that I'm looking for T averaged. Okay? Great. Now I have, so the other thing that's in here that I need to translate, well, we also have X becomes T, okay? The other thing is that this is where my interval starts because I'm looking at times that are between time 6 hours and time 12 hours. So this must be my A. So this is going to be my A, where I start considering time values, and this is my B, where I finish considering time values. Okay, so then let's go ahead and give ourselves a nice translation so that we make sure that we set it up properly. So we're going to use this, but we're replacing so I want to replace f of x in here. Right, that's the function that we're averaging over our interval. So I need to replace that with, I'm averaging the temperature, so I need to replace that with T of t. So that's 20 minus 5 cosine of pi over pi times t divided by 12. Okay, so that's the first replacement. We also need to replace, and I need to replace, right, I need to replace my A. I need to replace my A and my b with, and I'm just leaving room so that I reduce the number of times I open and shut my pen, so t1 equals 6, and t2 equals 12, right? The start time, the end time. And so I replace a with t1 equals 6, and b with t2 equals 12. Okay, so these are all of the things that I'm replacing. And now I can just directly translate this equation here. So I'm going to go ahead and do that. But I'm going to do it over here so that I have room and everything can kind of line up very nicely. So let's go ahead and do that. So I'm going to take this formula, and then every time I see a replacement, I'm going to replace what's written there. Okay? So I'm going to have that my t average is going to equal, so I have 1, and then this is over the length of the interval. So I want to go b minus a. I replace with 12 minus 6. And then I need to integrate over that interval, so that's again a 12 and a 6. And now I no longer have an f of x, I have a t of t. And this time I'll just write t of t, and then in the next step we'll actually write out what it is. But it's nice to do this also just to emphasize that t is your variable. So when I'm integrating with respect to t. So there's also this little swap here that I have to write dt, because I'm integrating with respect to t. Great. So now, in this step, all I'm going to do is I'm going to compute this to be 1/6, and then I'm going to actually write out what the equation for that integral is. The one thing I'm going to keep is, and I'm going to keep the bounds orange, so that when I plug them in the end, it's clear what I'm doing. Everything else is now going to become, well, maybe for one more step, I'll keep the blue so that you can see that replacement happening. But I'm going to take 1/6 here, which is just the 12 minus 6. That's not a problem. I'm going to integrate. I said I want to keep these bounds orange because it's going to save me a lot of confusion later. And now I want to put in my t of t. So I'm going to get 20 minus 5 cosine. So I have pi times t divided by 12. And then we remember we're integrating with, our function is a function of t, so I want to write dt here. Okay? Now, I can go ahead and integrate this. So I'm going to get, this is going to equal 1/6, and then I'm going to put parentheses here because I'm going to integrate now, right? And so so what's the antiderivative? The antiderivative of 20, not so bad. That's just going to be 20t, okay? The antiderivative of this, we haven't done substitution proper yet, but this is actually a good opportunity to see why we need to do substitution, because I want to make sure that when I find the antiderivative and I apply the chain rule, I'm going to cancel out, right? Because if I apply the chain rule to something with that on the inside, I end up with a pi over 12 on the outside. So I need something that's going to cancel that out. So I keep my 5. So I have minus 5 times, and then I'm going to have to cancel that, so I'm going to have to put 12 over pi. And then I can just do sine of pi t divided by 12. And then now I don't forget that I'm going to be applying this to my bounds because this is a definite integral, and so I'm applying it. So I have a 6 here, and in fact I'm going to actually write t equals. I think that can be kind of helpful here. So I'm going to have t equals 6 and t equals 12. Those are going to be the values that I'm going to put in. Great. Okay. So why do we believe this? The reason that it might be easier to see now why we put that 12 over pi into the antiderivative is if I took the derivative of this by the chain rule, I would get cosine of pi t over 12, but then I'd have to multiply that by the derivative of the inside function, which would give me a pi times 12, which then would cancel this out. So I would get cosine of this. Okay, so that's good. We did a good job there. And then we're going to have, so now I have to put in the top bound minus putting in the bottom bound. This is one of these things where I feel like it's a really good idea to do these things very carefully. As I say, at least 1,000 calculus students by now. And one of the things that actually makes a huge difference in how students do they actually carefully go through their work. And it takes a little while to get used to it, but it really can help. So for example, before I even plug in any t's, it can help to do an extra step where you just replace all the t's with parentheses so you don't get confused what you're plugging in where. Okay, so I would do 20, and then I would just put parentheses there, minus 5. Okay, I'm actually going to multiply these here just to save us a little bit of room. So we know that 5 times 12 is 60, so I can write 60 over pi. I'm just multiplying the numerators. And then I'm going to put sine of pi, and then here's another copy of t, so I just put parentheses there, divided by 12. Okay, and this is going to be the one that I'm going to put plug 12 into, but we know that we need an extra parentheses because 1/6 has to be multiplied by the whole thing. Or you could actually, it might be less clear that 1/6 is multiplied by the whole thing, and so actually let me write that slightly differently. Just do it in a way that's a little bit clearer to you, hopefully. Okay, so now I want to subtract, and then I want to write this whole thing again with parentheses again. Okay, so I want to write 1/6, and then I have 20 times parentheses, and then I have minus 60 divided by pi sine of pi times parentheses divided by 12. Okay, now that we have all of our parentheses just kind of left there, in the first one I need to put my 12 everywhere, so I put a 12 in the first one every time I have the parentheses, and in the second one I need to put a 6 every time I have the parentheses. And now this is just something that you could stick into a calculator, and the output that I'm going to get is going to be approximately 23.2 degrees Celsius. Okay, so let's kind of like go through everything we did. This is actually, you know, the average is kind of cool. You can take the average of everything in that interval all at one time. And we have a formula we can use, and it's not so bad. We just have to figure out how to translate things into it. So we have to, like, when we're kind of reading the question, we kind of want to figure out, it can even be really helpful to write your translation out carefully. Okay, so that I have, this is my new function, which also I look for the fact, this is very important. Notice, right, this is a function of t, not x. Okay, and where that's going to end up showing up, it's going to end up showing up multiple places, right? We have it's here, but it's also tells me what I'm integrating with respect to. So I have to do that very carefully. And then the other part in here, I'm looking for the average temperature. So I know the temperature function is the one I'm averaging over. And then I need to figure out when does the time start and when does the time end. The time starts here, so that's my A. The time ends here, so that's my B. And it's going to show up in two places. That's going to show up here in the denominator, and it's going to show up in the bounds of my integral. Okay, so I just kind of wrote that all neatly out for myself so that when I translated, I didn't make any mistakes. So then I put, in this one, all I've done was kind of substituted each of those things in. And here I just put in the function t, and when I just took 12 minus 6 here. Then I needed to integrate, so I needed to take the antiderivative. So I got the 1/6, right, that stays out. And then I have 20t, because if I take the derivative of that, I get 20. That's good. And then here, I have to pick up this 12 over pi because of the chain rule applied to sine, right? I know that the antiderivative of just cosine is sine, but there's something on the inside so that when I actually take the derivative, I end up applying the chain rule, I end up with something on the outside, and so I need something to cancel that. Great. Now I actually want to put in my bounds, and again, as I mentioned before, one of the things that I've found makes a huge difference in how students end up doing, it gets very tempting to try to go fast and see how much you can do in your head and so on. It tends to lead to a lot of unnecessary errors, and also as things get more difficult, it's harder to do them. So it's good to kind of set up nice methodology for yourself where everything is nice and clear and organized, so that in this circumstance, when I'm putting in the 12 and then I'm putting in the 6, I don't get confused. What I did everywhere is I replaced the t with parentheses before I put in the 12 and before I put in the 6. And then in the end, I got 23.2 degrees Celsius, right? Because I'm looking at an average temperature, right? The outputs of the temperature function are degrees Celsius in degrees Celsius. So this here is the average temperature, so it's going to be an average output, so it's going to be in degrees Celsius. If I was talking about the inputs are always in hours. But the average function gives you an average of the outputs. So you want it to be in those units. Well, great. So I hope that made some sense, and I'll see you in the next lecture.